Today we are discussing about another theorem, that is the number of vertices of odd degree in a graph is always even. In this graph we can see that vertices v1 have degree 3 and vertices v4 has degree 5, and this theorem always satisfies this property, that is the number of vertices of odd degree in a graph is always even. If we draw parallel edges, self loop in any number of vertices and edges, this theorem satisfies. Now we have to talk about what is isolated vertex, pendant vertex and null graph. A vertex having no incident edge is called an isolated vertex. That is, the isolated vertex is vertex with a 0 degree. Here we can see that V1 vertex and it has 0 degree. It is called isolated vertex. And a vertex of degree 1 is called a pendant vertex. Here we can see that there are 3 vertex and 2 edges, and V1, V3 vertex has degree 1 and it is called pendant vertex. A graph without an edge is called a null graph or empty graph. Here we can see that V1, V2, V3 vertex and there are no edge. So it is called null graph or empty graph. A graph is called bipartite if the vertex set V can be partitioned into two sets such that each edge in G has one end in one vertex and other end in another vertex. That is, no two vertices in two sets are adjacent. Here we can see that vertex set V can be partitioned into two subsets, that is X and Y, such that each edge of G connect a vertex of Y to a vertex of X. In other words, no edge joining two vertices in X and or two vertices in Y. And in bipartite graph, X union Y equal to V and X intersection Y equal to 5. That is, in bipartite graph there are two subsets and these subsets union is equal to total number of vertices and intersection of these two subsets equal to 5. That is empty set. Complete bipartite graph. Let G equal to VE be a bipartite graph with the partition V equal to X union Y. G is called a complete bipartite graph if each vertex in X is adjacent to every vertex in Y. In a complete bipartite graph, each vertex in one set is adjacent to every vertex in another set, and it is denoted by if one set contain m vertices and another set contain n vertices, then complete bipartite graph G is denoted by kmn. And we have to note this, that is complete bipartite graph kmn has m plus n vertices and mn edges. Let us draw a K23 complete bipartite graph. It implies that first vertex set has 2 vertex and second vertex set has 3 vertex, and we have to take it as X set has A, B vertex and Y has C, D, E vertex, and using this we can draw complete bipartite graph K23 A, B, C, D, E. A is connected to D. In a complete bipartite graph, each vertex in X, that is in A and B, it is adjacent to every vertex in Y. is a K23 complete bipartite graph. Then we also said that KMN has m plus n vertices and mn edges. We have to check that. We said that KMN, that is K23, has m plus n vertices, that is 2 plus 3 vertices. That is, here we can say that A, B, C, D, E, 5 vertices and mn edges, that is 2 into 3, that is 6 edges. We have to check it. 1, 2, 3, 4, 5, 6. There are 6 edges. If you have any suggestions, doubt, then comment below